Hello, this is Karl Freund with Cambrian-AI Research. Welcome to the conference. It's going to be a great couple of days, it always is. And I'm sure that the keynote addresses from Liputan and Arctigoose will provide some insights that all of you can benefit from in your chip design and investment endeavors. My role for the last 3 years, and now this time for my fourth AI hardware summit, is just to give you a lay of the land, kind of a who's who in the zoo view of what's happening in the industry, what are the major trends, who are the major players, and what are the things that I saw during the last year that are of note. Let's talk just a moment, however, about this year's conference. It's really about the system this year. Yeah, we're going to talk about chips. I mean, that's at the heart of all of these systems. But to turn those chips into platforms that can be used for extremely large and efficient AI requires an innovative system design. You can't get there by simply plugging a GPU into an industry standard server and then say, well, I'm going to let this thing crunch away for 6 months or so to be able to train a trillion parameter AI. Well, it would probably take a lot longer than 6 months. So most vendors today their strategies are not to be a merchant semiconductor provider. And primarily here, I'm really talking about the data center. We can talk about the edge in a few months at the upcoming Edge AI Hardware Summit. But in the data center, everybody recognizes two things. One, the value of very large AI is clear. And two, very large AI requires really good system design. And so they're all shifting to become, or started from the beginning to be, a system vendor, not a merchant semiconductor provider. Even the leader of the industry, or perhaps especially the leader of the industry, NVIDIA, introduced Grace early this year. That's not about them wanting to become an ARM server vendor. That's about them having the control they need to be able to build a cache coherent large memory system that can handle multi-trillion parameter AI models. Others are doing something similar. They're taking different technology approaches, but I would point to Cerebrus's recent announcement to Brainscale AI, Salmonova, Grok, and Graphcore are also building systems, not chips, so they can handle very large AIs. And I'd also point to two other leaders, AMD and Intel, and their exascale offerings and wins with the US Department of Energy. Those are not just GPUs plugged into servers. Those GPUs sit on the native bus, the native interconnect that is used to connect CPU sockets. They will now connect to GPU sockets. So all of this is being driven by several things. First of all, the need for massive amounts of memory, massive scalability, very high bandwidth. So with that, let's look at the vendors and the top 10 list that I think are noteworthy. We'll cover these very briefly. We don't have a lot of time. We'll cover AI benchmarks, MLPerv specifically. We'll talk about Synopsys DSO, which is the first of many innovations coming out to use AI to build better chips. From Synopsys, from Cadence, and even efforts from companies like NVIDIA and Google, who have published research papers in this area. We'll talk briefly about AWS, and the reason is not to talk about the inferentiate chip design, but really to share with you a lesson I think we can all learn from marketing and the need for optimization. We'll talk briefly about Google TPU V4, Intel Habana Labs, Graphcore second generation machine, touch briefly on NVIDIA Grace, and then we'll conclude with the Cerebrus wafer scale engine 2. So let's talk about MLPerv. As most of you know, if you follow my writings and research, I'm a huge fan of MLPerv. I think it will do for AI what SPEC and TPCC have done, or TPC have done for the data center industry servers. Now, the problem has been that nobody wants to throw results at NVIDIA unless they can beat NVIDIA. And frankly, it's hard to beat NVIDIA. Their technology, both from a hardware and software standpoint, is very hard, if not impossible to beat. And sure enough, in MLPerv training and inference benchmarks, they sweep the field. However, there have been some important news in the latest MLPerv results. First of all, Qualcomm, while their Cloud AI 100 is a little bit slower than an NVIDIA A100 platform, it's much more power efficient. In fact, it's the most power efficient platform MLPerv results have tested. And we'll see a lot more coming out soon in the next couple of releases as David Cantor and the MLPerv organizations and contributors are all committed to showing energy efficiency as a key attribute. Let's talk also about the other thing that was perhaps a bit surprising was the Google TPU V4. It's not surprising that it's a great platform. What's surprising is to me is they still haven't released it. It's still preview. With these kind of results, I can be pretty confident in projecting we will see that platform being released for general availability on Google Cloud. It's up to 75% faster than the current leader of available platforms, NVIDIA A100. That's quite, now, of course, you could say, well, yeah, A100 is 2 years old. But nonetheless, this is an excellent piece of engineering and design. The next thing I want to talk about is how you design a chip. Many of you are familiar with this. Art is using this in his keynote presentation as well, but I'm going to do a little color annotation to it. This all started using AI to run large-scale exploration of the various ways of laying out a chip. We're talking physical design here. And they came out with DSO.ai in May of 2020. And now Cadence has done something similar, sounds similar, this July, going after the physical design, the geometry optimization of chips, producing better chips, faster chips, more power efficient chips, and even smaller area. But these technologies are just the beginning. We'll see all of the AI, all of the EDA vendors and large users like let's say Google or NVIDIA or Intel perhaps will probably be developing some of their own technologies using their own AIs to go after both the behavior, logic, the RTL, the algorithms and the systems, and the structure, how you actually build the system from in terms of ALUs and registers, gates and flip-flops. This will create a cyclone of innovation, a cyclone of optimization that will help all of you produce better chips. And whether you want to optimize on power, performance, or area, or a combination of all three, which is the norm, AI is the magic tool in your toolbox going forward. Very briefly, Salmonova, Grok, and TensorTorrent, all very interesting technology companies, all three building systems, not just chips. And there's not a lot of new announcements since the last AI Hardware Summit. There's some. Maybe we'll hear more this week during the presentations that follow mine. I will point out that TensorTorrent did hire Jim Keller as president and CTO. Of course, Jim's famous for his chip design work, perhaps the finest designer in the industry, and that's significant. Now let's talk about AWS. Inferentia is a good platform. They've done a good job with Inferentia producing a very power efficient and high performance platform. So what I'm about to say is not news to them. I've already had conversations with them about their marketing of this chip, and what they're doing is they're doing out-of-the-box comparisons with NVIDIA T4. NVIDIA T4 is old. It's an old platform, but it's still quite heavily used on AWS Cloud. And they have good reasons for saying, hey, we're going to do an out-of-the-box comparison. Let's just compare silicon to silicon. And when doing so, they say, hey, look, we're about 70% cheaper than using the NVIDIA T4 on the AWS cloud. You can use Inferentia on AWS cloud, get the same amount of work done for 70% fewer dollars. This is in terms of cost per million sentences doing natural language processing. And that's all true. They're not lying. However, NVIDIA pointed out with a blog saying, hey, if you're using T4 on the cloud, here's the best way to get the performance you need. And by doing so, they were able to improve the performance by a factor of 10 using TensorRT and Triton Inference Server. That flips the equation from AWS being 70% cheaper to AWS Inferentia, I should say, being 70% more expensive on Inferentia than T4. That doesn't mean that they can't optimize T4. I mean, excuse me, Inferentia. Of course they can, and they do. But the comparison of unoptimized results, I think, is a bit ill-advised, because why would you leave 10-fold performance improvement on the table so that you can skip the step of using an optimizer for things like quantization or an inference processor to manage batch sizes, which is one of the things that the Triton Inference Server does. So anyway, my advice to all of you is to make sure your optimization stack and efforts are up to snuff, because that's what people will really use. Okay, Google TPU V4, as I said, it's very impressive. I suspect we'll be seeing it coming to GCP soon. It's very impressive technology, and we'll see what they're waiting for. They might be waiting for things like recommendation engine and natural language processing optimization results to be production ready and ready for GCP clients to use in production environments. Briefly, I'm running out of time. Intel Habana Labs. Gaudi is a great looking platform. I love its plug and play features from a 100 gig E connectivity standpoint. I love the density. I love the performance. And finally, they got a design win. And they got the aforementioned AWS, which claims 40% price performance advantage versus NVIDIA. But as we just discussed, there's a question of, well, is that optimized or not? If you look at their MLPerv results, Gaudi is not yet produced optimized results for training. So we'll have to see whether that 40% claim is another out of the box comparison, or whether that's optimized versus optimized, which is, I think, the better apples to apples comparison. We do think Habana Labs Gaudi will become a significant force in the industry. Graphcore. One of the best monetized, capitalized startups, a unicorn out of the UK, of course. They came out with their second generation chip, but more importantly, I believe they came out with, I think, a very elegant solution where you take a 1U pizza box designed by the same guys who did the Spark pizza box, and you plug and play with as many or as few CPUs as makes sense for the model, and that's a dynamically configured environment. It's still got a lot of work to do to demonstrate the scalability of this with the IPU Pod 64 and up to 256 and up beyond that. But I think this is a very elegant approach for large scale training of deep neural networks. Okay, number 8, Grace. I'm a huge fan. This stuff is good. I feel like a fanboy here, but what they're doing is completely changing the way high performance data centers will be designed. In fact, they announced the fastest design on, at least on paper, of a Grace-based future GPU supercomputer based on this architecture. You got 1 GPU per Grace, it's all interconnected over a fabric and all front-ended by a DPU, data processing unit. So I think this is going to be significant and will set the pace for coming years. Number 9, and I would give this the Innovation of the Year award if I had one. The Cerebras Brain Scale AI that was just announced at the Hot Chips conference a couple of weeks ago. They added a fabric switch called SwarmX to interconnect multiple CS2s, each of which has a wafer scale engine. And then they added a really cool innovation called MemoryX, where they're going to stream the weights from MemoryX through SwarmX to the CS2s, and then they stream back the gradients. And then the MemoryX system, not the CS2, the MemoryX system combines those and adjusts the weights accordingly, offloading the CS2 from that primarily scalar operation. They claim they're running models in-house, and their goal is to support 120 trillion parameter AI. Well, based on my research, that's about the size of the human brain, the cerebral cortex specifically, not the whole brain. And that may be scary, right? But this does not portend general AI. To go from 120 million parameters or synapses, essentially, to human intelligence requires more than hardware. It requires software that is simply beyond our reach today. And so while I respect those, like Elon Musk and Stephen Hawking and others, that warn us about the potential of general AI, I don't think this is the announcement of general AI. It is the announcement of some really cool looking technology that will provide a level of scalability we just haven't seen before. Okay, so where's number 10, you're asking? Well, number 10 is found in Cambrian-AI research, of course. I couldn't resist a plug for my new firm. Come check out our website, Cambrian-AI.com. There's a hyphen there. And follow us on Forbes, follow me on Twitter, and watch for our updated AI competitive landscape report. My goal is to have this ready for the 1st of October after I digest all the presentations you're about to see over the next 2 exciting days at the AI Hardware Summit. We had over 500 downloads of this report during the last quarter. So it's really, I think, helping people get a lay of the land, comprehensive review of all the major players. We need to beef up the coverage of Chinese players beyond just Baidu. There will be lower pricing announced on October 1st to make this more affordable and more widely available. So watch for that. Had to have a plug. Sorry about the paid advertising here. But thank you all very much for attending the conference. And thank you all for, oh, this is our family. This is our mascot. These are our mascots of Cambrian-AI. They're actually not Cambrian fossils. They're from the Devonian period, but still 425 million years old. They dominated the seascape a long time ago and died out during the Permian mass extinction. But anyway, AI is not going to die out. We're not going back to an AI winter. Have fun this week. Learn as much as you can. Network together. I wish I could be there physically with you, but coronavirus really prevented me from joining you. Thank you all very much. And now we'll take some questions and hopefully some answers. Thank you.